Hello, 8th grade math students. Mr. Lawrence here, and today we're going to try to figure out how many solutions a system of two linear equations has without doing any graphing. Yeah, without doing any graphing. Now, you may not have considered this before, but if we have two lines, a system of two linear equations, we might have a case like this where the two lines are crossing at one point, right? Well, that place is the solution. So in a case like this, we have one solution. All right. We might have a case like this where the lines do not cross, the lines are parallel, in which case there's no solution because there's no point that they have in common. Remember, to solve a system is to find out where the equations of the lines intersect. Now, a strange one is this one here. Can you tell that the green line is actually on top of the red line? They both go forever. One's not longer than the other. I made it look like the red one was a little bit longer so you could see them both. This is a case where they're intersecting everywhere, and this is said to have infinitely many solutions. Infinitely many solutions. Okay, so we could have one solution, no solution, or infinitely many. Those are the only possibilities. We can tell these real easily without actually graphing. So let's see here. To see how many solutions without graphing, first we're going to convert our equations to slope-intercept form. That's the key. We've got to be in slope-intercept form. I don't know if you realize it, but this one here, oh, hold on, okay. These lines here, the lines have different slopes. Yeah, they have different slopes. How do I know that without having an equation? Because they intersect. If the lines had the same slope, it would either look like the middle example here or the example on the right. So these lines have different slopes, okay? These lines have the same slopes, but different y-intercepts. And you can see that clearly. They cross the y-axis at different places, okay? This one here, the red and the green one, these two, I should say, they have the same slopes, but they also have the same y-intercepts. All right, so right there. That's going to be the key. So the first thing we're going to want to do is get the equations into slope-intercept form. In other words, get y alone. Then we're going to check the slopes. If the slopes are not the same, we know that there's one solution. Yeah, if the slopes aren't the same, there's one solution. If the slopes are equal to each other, then we're going to check the y-intercepts. You definitely want to write this chart down. It's a little flow chart. Check the y-intercepts. If those are equal, we have infinitely many solutions. It's a case where there's actually the same line, the same equation. If the y-intercepts are not equal, then there is no solution because the lines are parallel. Yeah, in algebra, we don't say parallel lines don't intersect like you might have said in the past. In algebra, we say parallel lines are parallel because they have the same slope. So let's take a look at a couple of these. All right, here we go. So here I have two equations, and I first have to, according to that little flowchart, make sure that the y is alone in each equation. Well, in the black equation of number one, y is alone. So I've got my slope is 4/5, right? On my red one, I have to get the y alone. So first I'll subtract 4x from both sides. Okay, so now I'm at negative 5y equals negative 4x. I could put plus 0, but I don't really need to, so I'm not going to. And then I'll divide by negative 5. And divide by negative 5. Those two negatives on the right-hand side will cancel out, leaving me 4/5 x. So it turns out that the slope for the red one is also 4/5. So they have the same slope. So this means either the lines are parallel or they're the same line. So there's either no solution or infinitely many solutions. I'll have to find the y-intercepts. Well, for the black equation, The y-intercept is -2. For the red equation, the y-intercept, well, there's nothing there, right? It's like there's a +0, so the y-intercept is 0. So this means that for this problem, for number 1, there is no solution. How do I know that? Because the slopes are the same and the y-intercepts are different. These are parallel lines, okay? Number 2, looks like I got to convert both of them. So the black one, I'm going to give myself a little bit of room to work here. We have 2x minus 3y equals 9. I'll subtract 2x, and I'll have -3y equals -2x plus 9, and then I'll divide by -3. Divide by -3, divide by -3. So then y is going to equal 2/3 x minus 3. So for that one, the slope is 2/3. Okay, the y-intercept is -3. All right, now for the green one. For the green one, I'm going to subtract a 2x from both sides. And then y is going to equal -2x plus 7. So the slope here is, oh no, I have a silly mistake. I'm not done with that. There's a 3 there. I totally dropped out of the problem. Yeah. Oh no, there's not. I was looking at the black one. Sorry. I do have it correct. Okay, so my slope is -2. I don't need to do anything else. I have 2 different slopes. Therefore, I know this has one solution. I don't know what the solution is, but I do know these 2 lines are going to intersect each other one time. Okay, 2 lines have to intersect each other once, not at all, or everywhere. And that's going on. One solution, no solution, or infinitely many solutions. All right, why don't you pause the video and give numbers 3 and 4 a shot and see what you come up with. Okay, if you haven't tried them yet, go ahead and try them. Here comes my solutions. So the black one is already done. I know that the slope equals 1/2. All right, the y-intercept, which I may not need, but it's -6. Okay, for the red one, I'm going to subtract 4x from each side. All right, and so I'll have -2y equals -4x plus 12, and then I will divide by -2. And so, with the red one, y is going to equal 2x minus 6. And so the slope of the red one is 2, and therefore there is one solution. How do I know? Because the slopes are different. These lines are going to intersect. Okay, if you haven't tried the green one yet, go ahead and try it, or the number 4 yet, go ahead and try it now. Okay. I'm suspecting that there's going to be infinitely many solutions on this, but let's see. All right, I'm going to have 3x plus 2y equals 8. I'm going to subtract 3x from both sides. And I'm going to get 2y equals -3x plus 8. And I'll divide by 2. Notice I do it in all 3 places. Y is going to equal -3/2 x plus 4. So my slope is -3/2. My y-intercept is 4. Okay, for the green equation, I have 6x plus 4y equals 16. Subtracting 6x from both sides, I'm going to get 4y equals -6x plus 16. Dividing by 4 will tell me that y equals, I want to simplify this, 6/4 simplifies to -3/2, and 16 divided by 4 is 4. And here my slope is the same exact as the black one, which means these lines are either parallel or the same line, and sure enough the y-intercept is 4. This one here has infinitely many solutions. Alright, that's it for the video. Infinitely, there we go. Infinitely many solutions. meaning they're the same line. They're going to overlap everywhere. That's it. If you need any help with this, please email me, see me in my office hours, whatever it takes. All right? Should be pretty simple. The key is, do you have this flow chart down? How many solutions? Okay. Convert to slope-intercept form. Check the slopes. If they're not equal, then there's one solution. If they are equal, you check the y-intercepts. If they are equal, there's infinitely many. If not, there is no solution because the lines are parallel. That's it, ladies and gentlemen. Mr. Lawrence signing off. Have a good night, everybody.